You all are welcome to our project Weather Monitoring System using NodeMCU and Anedya IoT Cloud and Grafana. In this tutorial, I will show you how I achieved my dashboard which achieved data which have data of weather surrounding which we can monitor through our dashboard from anywhere using the Grafana tool and Anedya IoT Cloud. So let's first of all I will walk you through the components which I have used. Currently I did not have any components, so I will show you how you can connect that, and we will see how I have written the Python script so that we can send the data to the IoT cloud and plot it in the Grafana, and which is observability and monitoring tool. So first of all, here we can see we have the DHT11 sensor which have three pins: data, VCC and ground. The DHT11 sensor is used for the getting the temperature and monitor temperature and humidity from the surrounding of air, which we have used to fetch the temperature and humidity for our project purpose. Then we have used the soil moisture sensor LM, which has two electrodes which is inserted inside the soil. If the current flow is good, then the moisture in the soil is present. The soil moisture sensor has various application in agriculture or irrigation sector for providing the moisture to the soil for very accurate. If the soil is dry, then the flow of current in the electrode will be minimum, from which we can see that there is less amount of current flowing. I mean less humidity is present in the soil. Then we have used the UV sensor. This UV sensor uses photodiode to measure the UV index ray, which photodiode converts to the electric current. Then electric current convert into the voltage, which the microcontroller can understand and use it. At last, the heart of our project, or we can say the heart of our project, is NodeMCU ESP8266. ESP8266 NodeMCU has built-in Wi-Fi. It has several GPIO with various communication protocol, and the reason we have used the NodeMCU is that NodeMCU has various versatile and more versatile and more I can say that advanced technology which we can use for our IoT project purpose. And let me walk you through the how our connections will look like. So yeah, here we are at the circuit diagram of our or you can say the connections, how you can connect the multiple sensor with the our heart of the circuit, or we can say microcontroller. So as you can see here, we have used the soil moisture sensor here. Here is the UV sensor here. Here is DHT11 DHT22 sensor, 0.96 LCD screen, BMP sensor. For you can connect any sensor which you like. BMP sensor is for pressure sensor, sensing the pressure. And here is an IC4051, which is basically a 8 cross 1 mux. So yeah, as you can see here, the UV sensor is connected, and soil moisture sensor both are connected with the analog pin of the A0 pin, which is connected with the mux. So you can see here, and the DHT11 sensor, or the what we can say is that temperature and humidity sensor is connected with the microcontroller with pin D3, and here we have a 0.96 LCD and BMP 180 sensor. So both the 0.96 LED and BMP sensor are connected to the microcontroller with I2C communication protocol, and they both are common with SCL and SDA. For both are connected with the I2C protocol, and that's it all about the circuit. Let's move on to the next part, or you can say the Anedya protocol, or Anedya portal, or you can say the target what we had to achieve for plotting and monitoring the data from Grafana. Hello, so yeah, here we are at the our prototype dashboard, or we can say anything like the target or task what we have to achieve. So here is a slave, or we can say the node, or basically node is a device which we use to fetch the data from any room or any device. Slave 1 has power, voltage, current, uh, RF or PF, and hertz for frequency. So this is what we have to achieve for uh, we can say observability and monitoring tool. The slave 1, slave 2, slave 3 represents the device, and we have used the dashboard for soil moisture, temperature, humidity, UV index, air quality index for that purpose. So slave 1 will take the data from the all devices, or we can say variables. These all are the variables which we are gonna use in our project. So that's it, and let's move on to the dashboard, how it looks, and we will see that. So yeah, here is the dashboard. As you can see, it is fetching the data from the all the devices or nodes. As you can see here, this is the dashboard which we have to build. So nodes are the slave 1, slave 2, slave 3, slave 5. Temperature from each of the devices, and humidity, soil moisture, UV index and UV index, which is plotted here. So yes, you can see here, and we have different panels for different observability and spikes. This is the time series panel here. This is the variation of a time series panel. This is the gauge visualization. The main purpose, or we can say the use of Grafana tool is here, is that it helps us fetching the real-time data from the IoT monitoring. For dashboard and monitoring, we have used the Grafana OSS, or we can say open source model, for accessing and plotting the data. It produces a central platform for visualizing data from various IoT devices, enabling real-time analysis and historical trend tracing. It has integrated diverse data, which means that it has the kind of, we can say, different data source plugins available, like InfluxDB, Prometheus. For this project or this dashboard, we have used Infinity plugin, which was beginner level, or we can say um, one type of data source which we have used. It creates real-time dashboard. As I said earlier, we can also help and set up some threshold which can help us set up alerts and notification. And one of the reason that we have used Grafana is that it analyzes historical data by leveraging I think all these features. Grafana transform raw IoT data into actionable insights, helping us ensure the reliability, efficiency and security of our connected devices and IoT. So yeah, that's all about it. The main key role between sending the data from our code, or we can say VS code. As I said earlier, I didn't have any uh, hardware with me, so I have used the code to send the data. You can say the code is Python script which sends the code to the API. So let's show you that. So yeah, here we are. This is the code which I have written for sending the data to the our Anedya API, which have the all the nodes, temperature, its connection key, and all its things for sending the data and submit data to the API. From this API sends the data to the Anedya API, and while fetching the data from Anedya API, we plot it to the Grafana. That's all about it. So main role here is played by the Anedya IoT Cloud. The Anedya IoT Cloud plays very crucial role in our story and plotting, monitoring, and the sensor data for IoT. The Anedya Cloud helps us IoT data management, real-time data. From sending data from NodeMCU sends data to the Anedya Cloud via Wi-Fi, which can be accessed remotely via Wi-Fi or for analysis and monitoring. So yeah, that's all it about. The crucial role here is played by Anedya IoT Cloud services. I hope you find this tutorial very helpful for your project journey. Thank you.